Hi guys, welcome again to Khong Driving, and this is part 3 of our video series on wheel alignment. And for today, the subject is about camber. Okay, C-A-M-B-E-R is camber and not chamber. Okay, so back again to basics. Just remember we said that we are setting up the car in a static mode for a dynamic application. In other words, the car is not moving, stationary, you're setting up the alignment in preparation for the time when you require it for a moving application. Okay, so what is camber? Camber, very simply stated, there are 3 stages of camber. First is zero camber. Okay, what is camber? Actually, camber is the angle of the front wheels. Look at the front wheels here. Now, the angle this way, meaning negative, zero camber, and positive camber. So just on this car, let's show you. This is zero camber, more or less. The wheels are straight up. Now, this is negative camber, where the wheel is slanted in, and this is positive camber where the wheel is at the bottom part is slanted in. This one, the bottom part is slanted out. In negative camber, the bottom of the wheel is further out, and in positive camber, the bottom of the wheel is in, or the top of the wheel is out. So here's a picture of extreme negative camber. I'm putting on this camera so you can see. Okay, that is negative camber. So you can see negative camber is when the bottom of the wheel is further out. And why do people want negative camber? Why do people want positive camber? Why do people want zero camber? Okay, so zero camber is, in theory, if you drove in a straight line for 100 kilometers, you will want to have zero camber whilst you are moving. You know why? Because when you are zero camber, your tire is in contact with the road. And I want to show you the effect, if it's wrong camber. It's the second picture here. This one, the second picture, there's camber wear. So if you look at the tire properly, this is toe wear, this is camber wear. They both look very similar, but if you look at this tire, the bottom of the tire is slanted upwards. The tire has actually worn into a cone. So that is because the car is suffering from wrong camber. So in other words, if the tire was like that and you kept on going without turning for 1000 kilometers, you find the tire wears out. It always wears into the pattern, or rather the footprint. And if this tire was in this position, you travel for 1000 kilometers, the tire will become like a cone, because it will wear down until it becomes flat. So in other words, once you put the tire straight, you find that it's a cone, and you find that it is worn on the inside. Why? Because you have got camber wear. And because it's negative camber. Conversely, if it was positive camber, you drove for 1000 kilometers, you'll find that the tire will wear as a cone like this, because the tire is like that. So at the bottom there, it just wears flat. It's just like you wear your clogs, you know, the Chinese clogs, the trompa. Well, if you step into somebody else's trompa, you won't be able to walk properly, because that pair of clogs has settled itself into the owner's footprint. So the owner could have negative camber or positive camber, depending on how he walks, and he will wear down the shoe. I have negative camber at the back, so my shoe always wears out on the rear part, on the right hand side. So my feet are actually like that. So that is the effect of footprint of the tire caused by the camber. Now, car makers usually set the camber at 0 or maybe slightly toe in. Especially cars with rear wheel drive, they will run it slightly toe in, because when they are taking the corner, and what happens if you have zero or slight toe in, when you take the corner, the tire will rub against the side and the car tends to understeer. If you drive at a safe speed, it will be okay, but if you try to push it, it will understeer. Why do car makers make the car understeer rather than make it oversteer? Oversteering is more fun, right? On the rear wheel drive, you power, the tail goes up, you correct, and it's so much fun. That's what everybody says. But actually, oversteer, where the tail starts to overtake the front, is more difficult to control than understeer, where the front just pushes away. So if the tire had positive camber and you're turning this way and you power too early, the front will push. Okay? So why do they want the front to push? Because the car stability control systems and you call it ESP, electronic stability program, or VSC, or whatever you want to call it, it means the same thing basically. So what they will do is when the car pushes, then the systems can come in to help you to stabilize the car. Now that's a separate matter, but the cure for understeer is very easy. It's very instinctive. You lift off. So when the car understeers, the first thing you do, see if your car is running out of control, what you do is you lift off with your throttle first, right? So when you lift off, the weight transfers to the front, and then you will get grip and you will turn. And when you lift off, it also slows down the car. In the meantime, the traction control and the ESC of the car, or ESP, would have throttled down also to cut power. So when it cuts power, your car slows down, you get grip, and you are able to turn. So the cure for understeer is lift off and turn more. So that is the natural way and easy way to get the car under control, and that's why car makers have the front zero camber. So you look at the Porsche 911, okay? It's got engine at the back, it's got tons of power. So if you look at it very carefully, you'll find that it's either zero or positive camber. Because when you pushing the power in a corner or into a corner, the front will just push instead of the tail whipping out, because all the weight at the back will make the car very tail happy if it was set to have more grip in the front. So the front tires will have less grip than the rear in a rear wheel drive, so that the front can push. So that's why car makers have zero or positive camber. Now, for people who want the car to handle a bit better, like you want to go racing, or you like to drive fast, then what you want to do is to have a bit of negative camber. Look at this BMW. Of course, it's a sports car, and the owner wants to have negative camber. So you see negative camber here, and perhaps, yeah, even a bit of negative camber in the rear. Okay, so you can see here, the front is negative, rear is slightly negative. So what happens is when you turn the corner, if your camber was like zero or negative, so if you were taking a corner and your wheels are positive camber, what happens is as you take the corner, the tire, there will be forces on the road acting on the tire, so the tire will start to fold in. So can you imagine the tire folds in, and then you end up with a lot of tire wear on the side of the tire up to where the tire brand is, okay? So that is wear caused by understeer and also by the camber. Because the camber is zero, the tire folds over easily. So what you need to do actually is to camber the tire a little bit, so that when it takes the corner, it will hold the road. So that is the use of negative camber. So negative camber in the front will increase the contact patch, or rather maintain the contact patch to be optimum when you're going through a corner. Okay, so that's why people dial in some negative camber. And negative camber at the back also is the same. It helps, but usually people try to have a bit more negative in the front for sporty behavior, yeah? So that, because the front actually takes more load. So the warning, of course, is if you have very much negative camber and you don't take a lot of corners, then you're going to end up with inside tire wear. The inside of the tire here, okay? The inside of the tire gets worn out because you are running negative camber. So therefore, the amount of camber you need to dial in depends on how you drive, where you drive. So usually for race tracks, if you are going, say, but a Batu Tiga track for the old guys, and which no longer exists, and of course Sepang track, cars will run more camber. Say for Proton, you'll be running possibly 3 degrees, 2.5 degrees. So depending on the power of the car, of course. So because that runs McPherson struts, and different type of suspension will have different requirements. Say for a car that has got Wishbone, then you don't need to run so much camber, because this is like a Wishbone. This is a Wishbone. With a Wishbone, the camber change is very minimal as the suspension moves. Okay, so as you take corner, there is very minimal camber change, so you can afford to run less camber, but nevertheless you still need a bit of negative camber for high speed driving. So for road cars, normally, let's say you're driving a Honda Civic or a Honda City or a Vios or an Altis or a Proton, you probably want to look at maybe 0.5 degree or 1 degree of negative camber. That helps, yeah? So you try to get that camber, and sad to say, in the old days, I remember the cars used to have adjustments for camber, but I think it was just that the market wasn't ready for it, and people didn't know what to do with camber adjustments, so they adjusted it wrongly, and we get all kinds of problems. And so the car makers decided not to put in camber adjustments. Now some of the vehicles that are around still have a lot of adjustments available, like for example on most of the trucks, the light trucks, they are actually adjustable for camber, caster and toe. So normal cars only have toe and no adjustment for camber and no adjustment for caster. Now, so for the normal car, that's good news. If you need to do your camber adjustment, this is an old one which I have kept for many years. I have no idea why I kept it. Oh yes, I know why. Because I use it for my alignment training. Okay, so this is called an eccentric bolt, and this is how you can change the camber. So on the suspension mount at the where it mounts to the knuckle, usually it's fitted to the top part of the two nuts, yeah. So the suspension coming down, they have the shock absorber, then they have two nuts, and usually this is on the top nut. Now remember, this center part is fixed to the part that moves in and out, and the outside part of it, like this part here and this part here, is supposed to sit on the shock absorber. All right, so this part is where the knuckle is. Now depending on, let's say you want to go negative camber, just remember this bolt only works one way. So you might look at this bolt. Okay, now I'm going to turn the bolt, and you see what happens is I turn, the knuckle has moved that way. Yeah, I turn it back, it moves back. Okay, it moves back into standard, and this way moves in. Okay, so if you want it to move in, you must put this inside. Okay, so when you turn it, it moves in. Yeah, so whichever side you want it to move, you must put this side facing that side. If you put it the other way, it will only move out, it cannot move in. So some of the alignment shops don't know this. They can put in the bolt, then they'll tell you, boss, your camber cannot adjust. Why? Because they put in the bolt the wrong way. So just remember, whichever side you want the thing to move, that's the side you put the thing in. okay? Because when you move like this, when you turn the bolt, it moves inwards, okay? So whichever side you want to move in, that's the way you put. So if you want to move out, you put it this way, yeah, away, and then you will move out. So it always moves in the direction of where this is, okay? So that is the Camber bolt, and you can buy them maybe 10 ringgit for a set. I don't know how much it costs, but in the old days it was a bit more expensive. But now it's about 10 ringgit or maybe 20 ringgit. You can get a set of 2. So that's for the front. Now, rear camber. Okay, let's look at front cambers. Sorry. So this one goes back in the box. I just want to show you some pictures. Okay, this is a very rudimentary camber gauge, but it's a very good piece of equipment. Okay, I used to have one. I don't know what happened to it, but this can be used to adjust your camber. So to adjust your camber, you need to take off the wheels. And when you take off the wheels, you cannot have your wheel alignment sensor fixed onto it. So how do you fix this? You take the camber gauge and you put it on the disc, at the top of the disc, this rotor, and then you set it to 0. Okay, so if you have measured your camber and you have now say positive 0.5 of a degree, and you want to get it to 0.5 negative, what you do is you fit it on, and then you dial this to either to 0.5 negative, and then you adjust the bolt until you get your 0.5 negative, or you put it at 0 and then you have to adjust it to the negative by 1 degree. So these are the readings here, and this is how you adjust the reading, okay, to set it to 0 by turning this dial here. And I move the knuckle using the bolt. So that's how it's done. But if it took you a very long time to understand, it's fine. You can rewind this video and see, yeah. And for the front suspension, for cars with Wishbone, okay, some of the older Honda Civics, yeah, the very fast ones, have got double Wishbone suspension in the front. And this is the one of the parts you can buy from the tuning shops. This part is adjustable. This is where the top of the knuckle is fitted. This is fitted to the body. Some of them have adjustable parts here, but that's not very good. The proper one is this one, so you can actually slide the ball joint inwards or outwards from this adjustment here. So that is how you do. Now for other cars, there's other than the bolts, you also have adjustable top mounts. Okay, so you can buy these. They are a bit expensive, but they are available for many of the cars, and they are available at many tuning shops. Yeah, so you can do that to change your camber. And for the rear camber, those who have the old Satria and Viras, and some of the cars that have a top link, okay, this is the part that links to the body, and this is the part that links to the knuckle at the back, and this is adjustable here. So there's one for left and one for right, and you can use this to adjust your camber at the rear. Okay, so the question will be asked, how much camber is the best camber? So there is always a limit, yeah. So just because you say that negative camber is good doesn't mean that more the better. Okay, so you've seen those people who do their cars with the rear tires like that, right? Well, that's being just plain dumb and stupid. I think they want to follow what some cartoon in Japan that shows the car very cute with the wheels like that. Now that's not a very practical car. I've seen some of them, they can hardly crawl along, and every couple of months they will have to change the tires because the tires are actually running just on one corner and grip is horrible. So negative camber is good for cornering, but up to a point. So for the normal people, I don't think you should go more than 1 degree, or at the max 1.5 degrees. So it all depends on how fast you drive and where you're going. Now, if you are living in Bentong and you come to Kuala Lumpur every day to work, then because of the Karak Highway with all the corners and all, you might want to dial in maybe 1.5 degrees of camber negative if you're driving very fast. Okay, otherwise maybe 0.5 degree or 1 degree is good enough. If you're going to the racetrack, maybe you want to run 2.5 degrees or even 3 degrees depending on the car that you have. So there's no hard and fast rule. The best is you have to, well, if you're in a more advanced stage, you'll be looking at tire temperatures. Okay, so the tire temperature is an indication of how much your tire is in contact with the ground. What you want is even temperature between the outside, middle and inside. That is the ideal, but usually the outside gets a bit more, so you increase your camber a little bit more to just try to compensate for it, to reduce the load on the outer edge of the tire. Yeah. So however, if you are not sure, the best thing to do is follow what the manufacturer has indicated on their data sheet or in the manual, because those are what you call general settings made in the interest of safety and also in the interest of having good tire wear characteristics on your car, and it's based on what the average driver will drive at. Yeah, so if you are very law-abiding driver and drive at normal speeds, just follow what the manufacturer has recommended. Yeah, but anyway, this one is part of a lesson to let people know a little bit more about alignment and what they're getting for what they're paying. And so remember, remember what I said about the run-out compensation, where they put the clamp on, then they roll the car forward, roll the car back and stop and take a reading. Yeah, that is the first part of the correct process of wheel alignment. So if any shop that you go to doesn't do that, then they are probably just taking your money for free and not giving you any quality. Alright guys, so that's it today for the camber part of wheel alignment. Thank you for watching, and if you like this video, please subscribe and please share with your friends, because this knowledge is very, very important. Okay, because our lives depend on the 4 patches of rubber the size of your palm that is in contact with the road. So if your palm is in contact with the road and it's like that, you're getting only half the grip, or if it's like that, you're only getting less than half the grip. So what you want is for the contact patch to be there, and the best time to have the full contact patch is, of course, round a corner. So the camber, toe and everything else in the car works together. Yeah, not camber by itself, but it works together to give you the best grip. And also remember guys, once you've adjusted your camber, you have to redo your toe, because any change you make to the geometry will affect other things in the geometry. Right? All right then, that's it for today. Bye bye.